So again, blank directory here, blank directory there. When we make a file with touch, text.test.text, that equates to something like making a new file, text document, test. So we can see we don't actually open it though. So we have test here, and we have test there. So that's essentially what the equivalency between those two directory structures would look like. And when we make a directory, we can equate that to making a new folder in Windows. And when we cd into my dir, that's essentially the same as clicking on that directory, and now we're inside that directory. And we can see that exactly what's inside that directory is nothing, and there's nothing inside that directory as well. So just trying to find those equivalencies between Windows and Linux helps to ease you into that environment a lot easier. So that was it for that demo. So I'm going to go through and kind of review printf. Basically, I'm just going to go ahead and make a printf.c and just talk about a few of the different things we can do with printf. So let's say we want to print out an integer, an arbitrary integer. We do %i, comma, and then specify that integer. We can see we printed out that integer. But we can also see that we didn't print a new line. So when the system continued accepting commands, there wasn't any new line after it. So what we would want to go do is go back into our program and add a \n right after that %i. Then compile it again, and then run it again. And now we have a new line after that integer. So let's say, oh, and just for reference, so there's a couple different editors you can use on Linux. I'm using the Vim editor. Typically, I'd say you should use the Nano editors because it's easier to use, but I'm just more familiar with the Vim editor. So let's say we wanted to print out a character instead. We can replace that %i with a %c, and then we can do a. Of course, that will print out the letter A. So we can also build more complex format strings. In addition to, well, let's start out like this. We can essentially just write arbitrary text inside our format string. Hello world. There's no percent signs in there. There never has to be. What the system does is whenever you say printf, it'll interpret that first string and it'll replace the format identifiers with the value you specify after the commas. So looking at this one, we can see that just prints out hello world. But if we want to say things like my favorite number is %i, then we can do comma and then say 7. Compile that again, and then go ahead and run it, and you can see that inside that format string, it replaced that first %i with 7. We can also add additional format identifiers. We can add as many as we want. The only thing that matters is you have to make sure you put the commas, you put them in the right order. So 7, 8, 9. So this I right here, will be replaced with 7, this one right here with 8, and this one right here with 9. Now, that is integer replacement, again with the %i. If we want to do something else, like a character or a floating point value, we have to use different format identifiers. So I'm just going to run this quick just to show you what it would look like. So again, we can see that those format identifiers are replaced with our numbers. So let's go ahead and just say numbers. And let's do a floating point number. So again, we replace that %i with a %f for floating point. Let's say we want to do 9.999. So again, save and close that. We can compile it, can run it. And we can see that it's 78999.
Sorry, how do you save and close Vim?
Oh, if you're in Vim, if you're in Vim, you don't again. Nano is I think a lot more straightforward. If you happen to be in Vim and you want to close it, it's a semicolon or colon. That little projector's off again, but that's a colon and then WQ and then return, and you'll exit from Vim. But yeah, typically I just say use Nano. I can personally type faster in Vim, so it doesn't really matter. So one thing to talk about when we're talking about floating point numbers is, as floating point numbers are represented in our system, we have a certain level of precision. That means that there will always be 6 digits after the decimal place, no matter what, as long as we're using a floating point number. Yep.
So you gotta like just type in for you like a tab, like starting to just press tab until it's close to the Vim thing.
All right. So one of the things we can do is we can look through the commands that we've run before by pushing the up and down keys. So if we want to go right back up to a command we just ran before, we can just push up until we get there. And if for some reason we want to just discard that line, we can just push Control-C. Now, if we're typing out a file path that we haven't used before, we can do nano print, and we can press tab, and it'll expand out, and we can push F, and then we push tab again, and it'll expand out the entire path that we're working on. So, we're going to just talk about the rest of the format strings that we talked about on Friday. So, %C again is a character, so that could be, let's make it Z. And we can see that that last format identifier is replaced with a Z. And the last one that we talked about was %S. So replace that with a %S, and then we can specify a string, which again is double quotation marks. A string is inside double quotes. A single character is inside single quotes. My string. And again, this exact value inside the quotations will be replacing this %S right here. So my string. So again, it's important. So the things that matter are you have to have the same you have to have the same format identifier, the %i for an integer, %f for a floating point number, %c for a character, and %s for a string, and they have to be in the same order that you specify them after you specify your format string.
So the string is saying like my string.
Huh?
Like the S means like the my string.
Yes, exactly. So this refers to position 1 after the commas, this refers to position 2, and this refers to position 3. So again, this is replaced by 7, this is replaced by 8, and this is replaced by my string. So does that clarify a couple of things that we were having issues with on Friday? you have something? Okay. Yeah, just click on the My Videos link. The DSC video server is really annoying right now, so I'm just uploading it to YouTube. So you can review this. The first video is really long. I'm probably just going to record the main components of the lecture for future reference. So that is printf then. What else do we have on our agenda? So reviewing the assignment, again, the assignment was create a C program which outputs a string, a character, an integer, and a floating point number. So again, there's the %s, %c, %i, and %f. So we can just go ahead and do that really quick, I guess. That's fine. We'll just replace our... Clearing the page? Yeah, so if you have a bunch of things on your page, you can just literally type clear. And it'll just reset up to the top. So let's say this is my int, my int %i, my float %f, my char %c, and my string %s. So let's keep it 7.8 or we'll keep it 7, then we'll go 8.1, and then we'll go %, and we'll just go z. And so in this string, without any of the format identifiers, nothing would be replaced, and it would just output my int, my float, my char, my string. But with the format identifiers, again, the system interprets this first string that we provided. This is a string just like any other, but the difference is the system interprets it and replaces what's inside it. So this is going to be replaced by 7. This is going to be replaced by 8.1. And this is going to be replaced by z. And this is going to be replaced by my string. So I'm just going to go ahead and close that and run it quick. And we can see that everything is outputted as we expected it. Now, just to review a couple other things, we can title our executable with the -o option on our GCC command, and we can say printf. So now instead of running a.out, which is the default executable outputted by our compiler, we can do /printf. Yep.
So why is it that you can't just type the number, like when you're writing it? Why do you have to replace it?
That's what we're gonna talk about it today. Well, we'll get in the very basics of talking about it today, but
Just because it's coding?
no. By all means, you can just type. You can type whatever you want in this string. It does not matter at all. You can type in literally 7, 8.1, z, and my string.
So why?
We'll talk about it today. So the things we're providing printf right now are what we call literals. They're actual values. But today we're also going to talk about variables, basically things that can store values. So I'll step back and we'll talk about variables. So when there's no format identifiers inside our string, none of the things that we specify after printf matter. We can still specify them, but they're not interpreted by the system at all. This isn't exactly good. So yeah, we can see that if I just replace that with like 780 and m and just string, none of these values are going to change anything because there's no format identifiers in our string. You can see it outputs exactly the same. The only time that printf looks at what you specify afterwards is after you specify a format identifier. So, if you still don't understand what's going on, let's get together and talk sometime. Everyone pretty good with printf right now, though? All right, so the second thing we're going to talk about today are variables. So let's open up. You can follow along if you want. It doesn't specifically matter. Variables.c. You don't. It's there. We'll just use that editor, and we'll make it'll be easy for everybody. You all ready? If you already are and you want to get out of it, just hit :WQ and then press enter. So one of the fundamental things about programming languages is the ability to store data. And we can store data in a couple of different ways, but the primary way that we can do it is with variables. So what we can do is we can essentially declare named variables that we can put values into. Now we've already talked about some of the data types that we can use in the C language. We can use an integer, a floating point number, a character, and a string. Now string's the hardest of them all in the C language, and we won't talk about that one for a while, but we'll talk about the first three to get started. So when we want to declare a variable, we first of all specify the type. We would say int for an integer, and then we give it a name. We say myInt, or we say whatever we want. We can give it whatever name we want. We can say number. We can say we'll go with number for now. And then we have number available to us. What we can also do is immediately give number a value. We can set number equal to whatever integer we want. We can set it equal to 10. We can set it equal to 100, 1,000, 10,000, doesn't matter. And then just remember that every single line in C ends with a semicolon. So now that we have number, what can we do with it? So we talked about printf before. So what we can do is printf, and then our format string identifier, %i, and then /n for a new line, comma, number. So can anyone take a guess and tell me what this is going to print out? It's going to exactly print out 100. So what we can do is, without changing this format string identifier, we can change this 100 to 200 or 300 or whatever. And whenever we recompile our program and run it, it's going to output whatever value we specify for number. Now, during the course of this course, we're going to learn how to, of course, change these numbers programmatically. So instead of hard coding them into the source code, so this is what we would call a literal. The number is always going to be set to 300 no matter how the program runs. But what we're going to learn how to do is basically take input to set number to different things as the program is running. So just again, to show you that this works, we can gcc variables.c, and then a.out, and we can see that it outputs 300. Yep?
Do we need to put a variable inside of the name, or can we do it outside?
All right, so that's a good question. So as a matter of fact, what we can do is, you shouldn't necessarily do this, but you can, what's the command in here? So you can cut, in Nano you can actually cut and you can paste a line. So what you can do is push Control-K and then move it up above int main and press Control-U. And as a matter of fact, this works just as well too. But it works for different reasons. So I'll just close it really quick and show you that it works. So it outputs exactly the same. But this isn't necessarily something we always want to do. At this point in this course, we pretty much want to keep all of our statements inside main. Yep.
I have a question. Main has nothing to do with an integer, so why do you put integer before it?
That's a good. We can talk about that one too today, actually. So yeah, and then we can use number as many times as we want to. We can say %i again, and we can put in number. And what will that output, do you think? There you go. So, integer is our first data type that we'll talk about. So just simplify this printf up a little bit. So just remember that we can specify as many statements we want to inside of these curly brackets inside our main. And basically, again, what main means is that's just where our program starts. So we'll move on to float. We can also declare a float with just saying float, or a floating point number with the data type float. You could say my float equals 300.333. And then we can output that exactly the same as before, just by giving it the floating point identifier and then saying my float. So again, we can exit out and GCC. Yeah, I'll pull it back in a second. A.out. And we can see it outputs almost the same. One thing to note about floating point numbers are they're really hard to do on computers, and they're not always exactly right. So when you output a floating point number, sometimes it'll just be slightly different, and you have to deal with that. So if you're outputting it and it's very slightly different than what you had before, that's just how computers work. It's as simple as it is.
So basically, don't worry about it.
Yeah. See, I'm typing 333, and if that's coming out the same and later digits aren't, it's just a matter of how computers work, and it takes a lot to explain how exactly that functions. But at this point, just don't worry about it if it's not coming out exactly right. Do you have a question? No? Question? Yep.
I just need help getting out the bin.
Oh, fun.
Alright, so let's go ahead and then
So, Vim, I
So the high grade variable, it says I don't have that. I'm gonna go.
Alright, so what you're gonna want to do is open it up. You missed a T there.
Okay.
But now you're good to go.
So, and the last data type we're going to talk about today is character. So we can do char, my char equals a, or any other character we want to. We can do capital. We can do special. We can do this. We can do that. We can do a character 7, which is not equivalent to a literal 7. It's not a number. It's just a character. It doesn't have any value. Not yet, at least. %C, and then my char. So after all of that, we're going to output 300, a new line, 300.333, a new line, 7, and then a new line. Just to make this a little clearer that that's a character, I'm just going to replace it with a, because everyone can agree that a is a character. Basically, anything that's a character is something you can type on the keyboard, whereas a number is something that you count, or a floating point number. So closing that out, We can see it outputs just like we thought it would. What else do we have to talk about today? Variables more. All right, so one of the questions, this might be hard to understand, and it's not necessarily even necessary to know. But one of the questions that was asked is, what is this int main up here? Why do we need to say int main? Why can't we just say main? So we're going to talk about that too. So one of the things that programs traditionally do is when they exit, they return a code to the system. And that code's always going to be an integer. So in order to inform the system of how our program functions, we can essentially say return and then a number. So by default, all programs that run correctly return a 0 to the system. So we exit out gcc variables.c, a.out, and you see that return statement doesn't change anything. But as a matter of fact, it does inform the system of how it exited. And you can see how a program exited by saying echo %, or $? And we can see that our program returns 0. Now, we can also do that for any other program that we're running on a Linux system. We can tell how any other program ran. So we can say nano variables.c, exit out of that program, and we can see that it also exited 0. It also ran successfully. We can do an ls, and we can echo, and we can see that it also ran successfully. But if for some reason a program doesn't run successfully, let me think of something that would run successfully. Yeah. We'll pause here for a second. We'll see what's going on here. All right, so you're using forward slash instead of backslashes. Yep. So there is a difference between forward slashes and backslashes. So this is a forward slash, and that's a backslash. So essentially, the differences between, on a Linux system, you'd use forward slashes for a path. So my folder structure. You use backslashes for special escape characters like %n, which is again a new line, %t, which is a tab, and so on and so forth. But going back to talking about return codes from programs. So we can open up variables.c again, and let's say that we think our program ran bad or something, or ran abnormally. We can return a different number. We can say 10, we can say 100. We can return any integer. So when we gcc it again, echo, we can see that it returned 100. And at this point, that doesn't matter much. We don't need to ever specify this. This doesn't matter. Because by default, programs that don't return anything, they're automatically assumed to have run successfully. So that's just something to keep in mind. That's why we specify that in there. It is required by the system, but it's assumed to be 0 under normal circumstances. So I think that's all I have for the lecture today. So if you've been following along, we can declare a variable with a data type and an identifier. So for an integer, a whole number, we can declare, we don't have to specify a value either. We can just declare a variable empty. It does have a value, but it's not defined by us. It's defined by the system. We can also define characters, and we can define floating point numbers, again, which are decimals. So for today, I'd like you to basically do exactly what we did in class. So if you're following along, this should be no problem. Basically declare an integer, a character, and a floating point number, assign each of them a value, and output them to the terminal with printf, and then submit it to day 4 in class.
Can I just turn this in?
Is it running and working?
Yeah.
If it's running and working, then you're good to go.
What should we name it then?
So
So just leave it in variables.
1 second, please.
Follow.
Does it really matter?